in a very, let's say, simplest way. So today we will have the presentation of the proposal made by the student to answer a design brief that was the tool we used to explore the method and approach of design thinking applied to Internet of Things. We will do this just by presenting what is design thinking, what has been the process we adopted, and then I leave the room to the 4 teams that will do their presentation. And the title of their proposal you can find here: the Hard Connect, Hard Face, Hard Support, a Computer Air. And then we will have just a closing session with some questions if there is any from the audience. So design thinking is a combination of methods coming from human-centered design with a set of mindset coming more from industrial design and creative design. This mindset has not been presented as a standalone concept, but more has been applied to the process that we try to, embrace during these weeks. And we did this not just in abstract, but try to apply to a real case. That is, instead to present this in the vacuum, we received a request from a company, a Danish company, that produce a specific tool that is used for sharing screen in educational context or in the office context. And they have a very clear mission and vision. So I will just present this short video that present to you what is AirTame, the technology of AirTame about.
Screens. They're everywhere. Classrooms, meeting rooms, waiting rooms, huddle rooms, staff rooms, green rooms, boardrooms. Heck, even restrooms have them these days. But what use are all these screens to you if they're displaying outdated content? In need of service? Or switched off? Well, none, to be quite frank. So why not take back control of your screens by using AirTame Cloud to control all of them from one central place? AirTame, making screens smarter.
They came about as a startup of 4 students from the Copenhagen University. After 2 years, their business grew up. There are more 50 people. And they received this year, at the beginning of this year, a grant or about $5 million just to extend, to improve its product. And this is what they asked to us, not only to us, but other universities too in Europe. It is the request that came from AirTame was to extend the functionality of their product for both the office and the school environment. For example, a direction that they gave to us was by using voice or control gesture. Okay, so this was been the request. We elaborated on that request according to the design process that we adopted, that is articulated in 4 phases. 3 phases were really addressed by this course. The first one was to empathize with the client, the user, okay, what is named the design research. So we had a copy of the interview made with a company. Then we had an interview with the professor, student, teacher at the university or in other place. And we also had benchmark phases where we try to explore different technology, enabling technology that could help us to, let's say, find inspiration from state-of-art technology. This was the first phase. And the second one was try to define the issue that should be worthwhile to be addressed and to start to ideate possible answer to that question. And we did this by just clustering the issue that came out of the interview, as well as the opportunities that were announced by our stakeholder. And by posing what has been named the how might we question, that is the question that should address really the issue that are worthwhile to be considered for producing an innovation. So we produced these questions. Out of that questions, we worked. But at the same time, or every Thursday, we had a lab exploring prototyping tool that should be instrumental to what are the more critical, interesting, intriguing enabling technology of today. That is a microcontroller, and we explored the microbit as a resource for using microcontroller in a very simple way that allow us to collect data and make it available for further processing. We elaborated also some tools with machine learning, in particular edge impulse that allow to build real models coming from different kind of algorithm for embedded system, and is a very, let's say, intriguing tool to be used. And then we also explored some tools for designing in a very simple, easy way voice user interface, both for Alexa and for Google. These has been a kind of tools that are very useful when you start to prototype your solution, so that you can create a proof of concept in a very simple and effective way. And then we went to the process of started to prototype, and we went from the basic of prototype, that is just producing some concept that were just, let's say, blueprint for potential solution. Then we developed some simple scenario of application, and then let's say just the beginning of a storyboard that should show how the solution should work. And what we will see now, I will leave the room to the proposal. We will see how this request of improving the technology for sharing screen for the educational domain has been addressed by the 14. Okay, so they are providing a potential answer to specific issues that were identified along the process. And we will start with the first example, okay, with the first project that has also, let's say, a proof of concept, a working prototype of the technology that they are proposing. So I leave the room. Okay. No.
All right. Thank you, Antonio. So we are AirConnect. We are a new way to connect and send content to the entertainment under 30 seconds using QR code technology. Now, we understand that sending content to a screen is a hassle. We noticed that when we were with Sinopoly's office, it was very difficult to you mentioned it was very difficult to start these connections and design content, especially when someone's new to the office. And same with the classroom setting, students don't have good opportunities to share content quickly to their professors during lectures. So we're gonna give you a story. So this is Pedro. He isn't sure if he saw the Riccati equation on the board correctly. He's in class. He's going through trying to solve this problem. He has his work here on the left, but he doesn't know exactly how he can ask the professor and get a quick way of showing the professor, hey, is this correct? So we wanted to solve this issue. The professor can put up a QR code that connects to a dashboard or a central control to the student. The student can scan the QR code and then have their send content such as PDFs or images, or even a dot cam, where they can use their phone's camera to show their homework to the professor on the screen. And yeah, so there it is. Pedro can scan it, and scan the QR code. And this was mainly inspired by the Edge Impulse technology, where Edge Impulse was, so you can input data very easily from your phone by taking pictures and uploading them. So using that inspiration, we can have dot cam footage from the homework assignment, and then now the student can show the professor what work they have. Now I think Lucas is going to share another story how this can.
All right. I think this can work even outside the classroom from students, and especially we took big inspiration from our interview with Dr. Sinopoli, where people who are not affiliated with the university come in. I mean, here's the example of Elizabeth. She's a guest lecturer, or anyone who wants to have a meeting, since these screens are all over the university, right? And I think one of the big problems that we found from other products was that in order to share your screen, you need to either have some sort of Wi-Fi password or an app or something like that. And that's just too much of a hassle for especially someone who's going to come here once and then not come back again. So one of the important features of AirConnect's feature is that it will automatically recognize when this is a new user, and it'll create an account for her as soon as the QR code is scanned. So that's the other example, and we can actually show this working, sort of. So now I'm going to pretend like I'm one of the students, right? I have my practice final exam tomorrow. I actually don't understand, so if you can help me with it. I can quickly scan the QR code. And you stop sharing your screen so I can go in. And you're like, yeah. And now you guys can all see what I'm doing, see what is wrong, and hopefully help me. Yeah, this exam is tomorrow, so like it's really important.
Yeah, so the big benefit, like Lucas and Julio have both said, is that anyone can connect to this extremely easily. There's no sort of added hassle. It's a quick, take a picture of the barcode and you're good to go, right? So the question is though, well, how does this actually end up looking? So the idea is that we would have a separate thing for students and for presenters. So students would be able to upload material, and then presenters would have sort of a central control panel where they can manage all that material. So if we take a look. So we're just going to go over some examples of what this control panel might look like, right? And things that professors would see. So one is this thing saying, Evan wants to share live footage from his camera, right? So this is exactly what Lucas was just talking about. And he's saying that he thinks he can demonstrate how to solve the problem. Another one might be Robert saying, hey, I want to share this image, professor. Can you show me where I went wrong here? Right? Like I'm doing this problem. I have no idea what happened, but I got a totally different answer from what you have on the board. And then even another example, right? So Meredith is saying, hey, I want to share my screen here, right? And I'm getting this error. I'm on Linux. I don't know what the hell's going on. Can you help me out? So from this, right, the professor could put her screen up on the board, could walk her through it. The students would be able to see what she's doing as the professor tells her what to do. And if they have the same issue, then they can make the same corrections. And then we would also have this sort of scrolling comments window. So something you might see from like an old chat room. And so you have some comments from students, like, I wasn't sure what happened with step 3. Could you explain a little more? Or, you know, maybe you're running a little late and the class is already over. You should have ended 10 minutes ago. Things that professors want to know as they're going through. So instead of students having to raise their hands, they can just send questions easily to the professor in real time. And then lastly, we'd have this sort of feature, which is a poll management feature. So a lot of classes use these sort of different kinds of poll websites where students have to go to all these different websites or get an app. This would allow you to just do it through Airtame's website. and you'd be able to send polls, ask students questions. You don't need eye clickers anymore. It's a much more simplified process. And then just putting it all together, you'd have something that looks like this. Obviously a bit better, hopefully, but this is in general what you would expect the professor to see and be able to manage. So yeah, thank you guys. Appreciate it.
Thank you. Okay. Now we have the second theme.
Okay. Hello everyone, we're the airface team, and our team kind of go hand in hand with the Air Connects who just presented just now. So basically they brought us a really great way of sharing our content, try to communicate with the professor in class. But what if you like the professor is just like writing on the blackboard constantly, not even turning his or her head back to the audience, like he just doesn't even notice you. Like how should you like let them know that you have a question in the first place? So that's what we're trying to tackle here. And just kind of starting with a background story. So we heard this story of a college freshman coming to college, really passionate about chemistry, but then she kind of walks into this like huge auditorium with just like hundreds of students, and just like it's basically hard for the professor to pay attention to every single student at the same time. And if anyone raises their hand, like the professor may not even notice that. So it's just really hard to engage in the class or but actively asking questions. So kind of after several lectures, just due to this like lack of engagement in class, the passion towards chemistry of the student just kind of dropped, which is really unfortunate. So, but in this case, we can definitely blame the professor, but at the same time, if there's a better technology that helps the professor to get real-time feedback from the students, like our students are kind of feeling boring or they kind of sleepy, or if anyone want to raise their hand and the professor is just too busy to notice that, is there a way to notify the professor what is going on in the audience? Like, are the audience feeling happy about the lecture? So yeah, that is essentially the challenge we're trying to tackle here.
So the first solution we decided on for addressing that problem about the professor maybe not seeing people raise their hand, maybe wanting to wait for a natural pause in the lecture for questions, wait until they can finish something. And like, I know I've had this happen where I've been like sitting in class and I'm like, oh my God, I can't keep my hand. And like, it's something that inspired our thinking, especially me. On Zoom now they do like hand raise detection where if you like start to raise your hand, it'll be like, are you trying to raise your hand? It kind of gives you a pop-up, and then if you are, that gives like a little hand raise emoji that can help. That way you're not like sitting there trying to raise it. You can just like put that up, and that can be a nice like visual reminder for the professor that there are people who have questions, so they know that, oh, I should find a stopping point so I can ask people that. That's one way we thought to address the issue with how students can more easily ask questions during lectures and communicate to their professor that there are questions.
And also, I just want to point out that this is really feasible because after the pandemic, we really have a camera in every single one of our classrooms. So the hardware part is already solved. We just have to solve the software part, and just taking benefit of the cameras around here to increase classroom engagement as much as possible. And yeah.
Another application of a similar technology would be mood detection. So the main purpose of this would be to gauge how students react to different methods of teaching. And so it could also be it could be an effective tool for feedback for teachers based on different methods that they use. There are a wide variety of available software to gauge someone's mood, but some of the main ones are Google's Teachable Machine and Nolda's Face Reader. So basically what they use is deep learning to go through massive databases of these different moods and to try to find patterns there.
And similar thing with the feasibility for this one, like there's already software and hardware present that is capable of doing this, but it has not been implemented in a learning setting. Like it could be alongside the Airtame.
And I'll,
Some limitations are that you would need to select one camera, and if you ever want to use it in an auditorium or large classroom, your software will have to be able to process this at a large scale with many faces at once.
and so kind of to actually achieve these, like it can be hard to detect like whether a student's really trying to raise his or her hand just by camera, but we kind of went through this kind of simple prototyping process along the semester, and I'll just kind of show like some of the explorations we have in terms of technology that can help us achieve these features. So the first one is what we covered using Google's Teachable Machine, and this is Giovanni here. And so basically we train a model that that can tell you like what gestures you're trying to mimic. We have like output here as Y and as C. So as you can see, as Giovanni kind of raised both of his hands, it's kind of detecting as a Y, and then when he put this gesture, it's like a C. So we just found out that the Y and C are really like kind of not simple letters in terms of shape, but really a hand raise could just be a gesture of like an I or like a 1. So we just figured that this exact model can be just transferred directly to a hand raising detection, where we're essentially trying to figure out if the user is trying to make a gesture like vertically this way, like a letter I or something. So yeah, that is how we're trying to achieve the hand raising detection. And we already see proof of concept here with all these like complicated models that has a really high success rate. So yeah, that's for the gesture detection or hand raise detection. And we also can explore a prototype for sentiment detection or like mood detection. So essentially, we're also using the teachable machine here. And what this does is basically it takes input from the camera. So this can be like a camera in the classroom, and we'll just point that to each individual student. And then, so the output of this is determine, this is kind of abbreviated, but it's just saying if the student is trying to sleep or like feeling sleepy and turning his or her hand kind of to the left. And the bottom one is kind of sleepy to the right. And as you can see, if I'm trying to get sleepy like this way, it'll just tell that this student is feeling sleepy, and maybe the content of the lecture can involve more engagement to make everyone engaged, and so that they don't really feel sleepy. And the other way is kind of similar. So yeah, this would be a really good start for mood detection, where basically we would just kind of scan the whole classroom and just kind of calculate like maybe how many % of the students are kind of sleepy, how many people are actually engaging. Maybe you can detect that by like the nodding action, and then the result of this would just be so we're trying to get feedback to the lecturer. So we have these like panels here, like screens here, and then the end result, which is essentially can be as simple as an emoji, just kind of showing maybe this is showing like the class is happy about the lecture, everyone's actively engaging, and maybe this one is just kind of one of those cases where people are kind of feeling tired. It doesn't even have to just be simply from the lecture, or maybe it's just the finals week and people are just coming to the classroom just kind of tired, and maybe getting this feedback can help the instructor to maybe come up with some more engaging content, or asking some question, go back and forth with the classroom to just wake everybody up from the tired or the tiring situation like a final week or something. So yeah, that is how we get feedback to the instructor, by using hand raise detection and sentiment detection. And we come to a conclusion.
Yeah, so using these integrations, we have a wide variety of options for having better engaging classrooms and allowing teachers to get larger variety of feedback from students. Yeah, so these interactions can be incredibly simple and have very quick response times. Yeah, and so these are some of the examples that we found that use deep learning to help teachers improve classroom experiences.
Yeah, and just mention one last thing, like, so when we were kind of thinking about these, we know that camera is always kind of a privacy sensitive issue, and since we're kind of scanning everyone's face, that's why we come to the idea that we're just gonna make the results simple. Like, we're not gonna say like this specific student is feeling sleepy. That's just not really good for privacy issues. So the end result is just like a general mood of the whole class kind of compiled
the
into one
average-
emoji. Yeah, the
the
average
average
of the
kind of mood.
classroom. So yeah, like all the data is gonna be processed in some kind of like cloud or something with like huge privacy protections. So yeah, hopefully this works. Yeah. Yep.
Okay, now.
Okay, so our product is air support, and the goal of this is to provide immediate tech support to classrooms at WashU and institutions like it to decrease the time spent troubleshooting technology in the classroom. So this is our friend Cassie. She's 20 years old. She's a student TA and RA here at WashU. During her time as a TA, she struggled with giving presentations in campus classrooms. Central tech support is based out of ESE and can take up to 20 minutes or longer at night to come and help.
So her recitation sections are pretty short, only being 50 minutes. And so the time setting up the screen is pretty significant in terms of being productive for her and her students. She has difficulty sometimes using the technology and doesn't really want to waste time with spending energy into the non-user-friendly devices. And this also causes problems where students start to disengage, and so their time is just being wasted even more.
So here's the story of how Cassie's most recent recitation went this past week without air support. She walked into the classroom, greeted her students, and sat down at the desk. She turned on her laptop and connected it to the room's AirTame device through the desktop application. A single tear rolled down her cheek as she realized that the device was not connected and it wasn't showing up on the screen. She tried restarting her computer and replugging in the HDMI cable to the TV, but she wasn't able to get it connected properly. So now it's been 5 minutes already into her recitation, and it's still not working. Without any other options or a clear way to diagnose the issue, Cassie decides that she has to call campus tech support. So now it's been 10 minutes since the expected start time, and her students warn her that they have other classes to attend and they can't wait all day for her to figure this out. So she finds the phone number of the WashU on the WashU IT support website and speaks to a team member over the phone. Unfortunately, they're having a busy day, and she'll have to be put in the queue of classrooms that are waiting for on-site assistance because there are no tools available to fix the device remotely. So the representative explains that they will be also coming from the opposite end of campus, as Nisha mentioned. So it's now been 20 minutes since the start, and her students have become restless. They've started writing comments about her in their course evaluations, and it's not looking good for Cassie. So WashU IT calls again to tell her that they're finally on their way. After 30 minutes, the students are even more restless, and Cassie must find a way to fix it as quickly as possible in order to preserve her reputation. By the time the school tech support member finally reaches her, all of the students have graduated. It's been too long. And it turns out that while she did ensure that the TV's HDMI cable was connected properly, the other side that was connected to the actual Airtame device was slightly disconnected. And by opening up the AV cabinet and replugging in the cable, the issue was resolved just within seconds. But this shouldn't be Cassie's responsibility.
Yeah, so let's rewind and see if this situation, how the situation could have played out differently if we had something like air support. So again, Cassie walks into her most recent classroom and still has trouble connecting. But then she sees a help button in the app, and the help button would also exist on the physical device, and she presses it. And sure enough, sooner or later, she hears a voice saying, "How can I help you?" And this is Airtame Aaron asking her what he can do for her. And she says that she's having trouble connecting. And upon examining his admin dashboard, Airtame Aaron observes that no input devices are connected. So he directs Cassie on how to check the input devices. And if needed, Cassie could also use her phone as a camera to show Airtame Aaron the cables in the classroom. After ensuring that all of the inputs are connected to the TV, our helpful friend Airtame Aaron instructs Cassie to check the other side of the cables and make sure they're securely connected to the Airtame device. Seconds later, she sees Airtame Aaron's friendly face on the TV. The students rejoice, and they can continue learning how to find the third integral in the fifth dimension. So why does this matter? Cassie's story is not unique, and it's far from it, actually. We may be slightly biased because we're all in technical fields, but especially in the age of Zoom and hybrid learning, fast tech support has become more important than ever. And live help would drastically decrease wait times and help students focus more and give more time back to the professors in class.
Instead of wasting time for WashU Tech team or hoping that professors can diagnose the problem themselves, we want to use the Airtame app already installed on the computers to give access to an Airtame employee that would be able to see your screen to accurately assess the problem. This would provide immediate tech support at the touch of a button, both in the app, physically on the device, and through voice recognition, instead of a 20-minute wait away. Furthermore, there are extra benefits such as a support representative being able to see device information from an admin dashboard, which was used in Cassie's example.
And the best part is how easily this solution could be implemented into the existing Airtame infrastructure. There's already an app available for all devices and all operating systems, and a help button would give the option to start an audio or a video call on the device or on the physical Airtame, depending on the situation, which gives the user as many options as possible, especially if they don't know what their issue is. They can just click the help button on whatever device is working and find help through some measure.
So this is great for the user, but why should Airtame go ahead and implement this? And the answer is that this would generate 2 additional revenue streams for Airtame. The first would be a direct revenue model, and Airtame would offer this support through something like a call center, and this would be intended for smaller teams or organizations without dedicated audiovisual tech support. The second revenue stream, and the one we kind of explained, might be one where they would license technology to larger organizations, whether it be university, large corporate offices, or maybe even theaters. And they would allow the university's existing IT departments to make use of this technology so their representatives could be behind it and they could have more custom integrations with the other software and hardware that those companies support.
So we wanted to tie this back to what we've learned about the design thinking ideals and the design thinking process overall. So being under the tutelage of a psychologist, we wanted to bring in a quote from famous psychologist Erik Erikson. "Life doesn't make any sense without interdependence. We need each other, and the sooner we learn that, the better for us all." Presenters shouldn't have to worry about anything more than connecting to their device with just a few clicks.
Our idea would allow users to focus on their work and humbly rely on Airtame to make their presentations as seamless and as user-friendly as possible, which is Airtame's ultimate goal.
Okay. Now the last visionary.
Hi, I'm Alec. This is Aaron. This is John Harry, and we're here today presenting on behalf of Compute Air, a proposal for classroom use. Man. So the idea right now is that online there are a vast variety of resources available to students to help them solve various types of math problems online. And ideally, high school students would be able to use these platforms to solve problems in algebra, calculus, trigonometry, and they could potentially even see step-by-step solutions or receive quick answers for computations that would then allow them to focus instead on the concepts behind those calculations. The problem is that these platforms right now are somewhat inaccessible for a variety of reasons, whether it's due to a complicated interface, a lack of integration with pre-existing technologies, or simply a lack of awareness about these platforms. Students, specifically in high schools, are failing to utilize what is available to them online. Additionally, those students that are using these platforms often do so while doing homework. And instead of utilizing them to help further their understanding of the material, maybe by computing something so that way they can focus on the bigger picture, they're instead utilizing it to simply solve the problem, complete the homework, and move on. And so what we've done is try to come up with a solution for utilizing this within the classroom. But first, I'm going to hand it over to Aaron to speak about and illustrate a particular problem that a student could face.
Wrong person.
Oh,
I'm actually
sorry.
doing it. So this is Sarah. And Sarah is a big fan of math, but as her classes have gotten longer and the problems have gotten more complicated, she has had difficulty keeping up, making her sad, as you can see. But she still loves learning about new concepts, and she gets bogged down in those complicated calculations that seem to come up when you get later in school. So while everyone else has moved on, Sarah struggles to arrive at the answer. And the question is, how do we help her? Well, if Sarah were able to use her voice to interact with the equations, she would have an easier time coming to a solution. In addition, it would be great if she were able to build equations in a more easy, more visually intuitive way, allowing her to understand the material in a deeper way.
So our thinking was to sort of create some sort of a platform or an extension to Airtame that would allow somebody like Sarah, who maybe is having trouble with sort of the specific calculations, writing everything down, keeping track of these long, maybe multiple pages of calculations, give them her a more sort of intuitive, easier way of really visualizing how these equations are working in a more interactive way that's sort of less about just being able to have really organized notes. So our thinking was to create an extension built directly into Airtame that lets somebody create an Alexa skill, which lets them interact, speak with Alexa, and essentially fill in the blanks for an equation in an interactive way, and then get the answer through there. But not only would they be interacting with Alexa, they'd also be the ones that were building the skill and understanding exactly what the different blocks are that sort of connect together to create this equation in order to really understand how the equation works, what the different inputs are, what the output is going to look like, and other things like that. So we can look a little bit at how this would look. So we start in the Airtame panel or the dashboard, and from there, a student can go right ahead and add a new Alexa skill. And from there, it'll bring them to a site called VoiceFlow or something like it, which essentially allows users to, in a sort of a drag and drop, pretty intuitive way, create a almost like a storyboard where it sort of brings them from the first input to the next, and then eventually can spit out an answer from there. And it's all very easy drag and drop interface. And it would let somebody like Sarah to basically allow them to go through and really understand, all right, I'm adding this block, but why am I doing that? And really understand each variable that's inside of the equation. And from there, they'll be able to export the gathered values directly to Wolfram Alpha, which, as mentioned before, is a really powerful computational engine. And we'd be able to use their API to send data and eventually receive data back from them. And finally, after that's all done, the student can save that Alexa skill and add it directly to Airtame for future use, and they'd be able to interact with it whenever they wanted to directly from that device. And we also sort of thought that something like this could also be good for teachers as well, and be able to provide students maybe with Alexa skills that they can sort of share with their students and allow them to interact with it that way, or just sort of perhaps another way for teachers to really find a more interactive way for students to engage with the material.
Yeah, as far as feasibility goes, I mean, it was pretty clearly outlined. We know like each step can interface with one another because like we investigated the APIs. The main thing we are unsure about is specifically how Airtame and the Alexa skill activation API would work, just because we don't have access to Airtame software. But otherwise, we know that it's a very practically implementable solution.
And so as we conclude, we just want to read this quote from one of the foremost experts on integrating technology and education, David Warlick. We need technology in every classroom and in every student and teacher's hand because it's the pen and paper of our time and is the lens through which we experience much of our world. So as we think about Airtame, as we think about being able to utilize these resources in the classroom, it's imperative that we think about opportunities for us to help students in any ways that we can. So by integrating Alexa and Airtame, we can open up a wide range of possibilities. Not only would we allow students to better learn material, but they'd be actively engaging with it. So they're not simply following the teacher's notes on the board and writing them down, copying them down. By utilizing Alexa, they're creating these skills, one, via Alexa, and two, by thinking about the equations in different ways and thinking about how you could then plug them in to solve while still being able to focus on the bigger picture of the concepts. And as engineers, it's really our responsibility to be thinking about these students who truly are going to be the pioneers of the future, the pioneers of tomorrow. It's really truly incumbent upon us to think about what we can do to further education in the classroom. And so that's why we want to put this quote by Mr. Warlick at the end here, because we're not merely creating solutions for one individual person or for one individual environment, but as a collective, we want to be thinking about the greater good and how we contribute to that and further education for students all around the world. Thank you.
Thank you. Okay. Thank you to all of you. And now we have some time for a question and answer session, mostly from Bruno. And you, of course, are really welcome to ask any question you want.
They've seen all each other's presentations?
Yeah, they have seen each other's presentation. Yeah, it's been discussed during the last 2 weeks. Yeah, sure.
First group. So first of all, that was very impressive, very creative solution. That was great. So when it came to my office, technology sucks. Extremely frustrating. So although there were, of course, some good you guys went beyond efficient ways of actually enhancing functionality. With respect to the first group, right? You develop a solution which is that was your goal. What are you trading off? Are you giving up something? I don't think.
Well, you're trading off like authentication. Like, so when people scan the QR code, they're always earlier this week when we're trying to see how can we like identify who's trying to send the content. And the best we could come up with was like have the user have a username, but then any way of like authentication. So, yeah. I thought that, however, like in spite of like the trade-off, I didn't think it was such a like a big problem since the QR code is only going to be like displayed in the classroom. It's a local thing that's happening. Not like someone from outside the classroom can get access. So that's why it was almost like bypassing the whole two-factor authentication thing. I think the biggest concern is like if many people in the room want to try to play a prank or something or interrupt the screen.
Yeah, that's fine. But for instance, the next question then is persistence, right? How long is that code going to be valid? Somebody uses it takes a picture, and then uses it in the next class. Is it going to work?
You can create a new every time you boot it up.
Well, I understand that. What if you know the QR code would work or not? Did you think about developing methods to prevent that from happening? Right? You give validity, limited validity to that.
I think it could be like easily. Like you can make the QR code expire like after every time it's going to shut. Like part of like the shut. Like you can turn off the airtime of the TV. It'll like wipe out that QR code, and when you turn on, it generates a one. Yeah, and then also there could be a setting on it and generate QR code.
And also just how you make it expire in practice. Like you just have it be like the website contaminated with some token, and then the token is valid for a period of time. And then if you connect to the website with all token, it sends you to say this code is.
Yeah, I think what we were really trying to avoid was trying to make an account for have a Wi-Fi.
Yeah, I understand.
That was like the whole. I think that was just a challenge, I guess. It's like simple but complicated like that.
Yeah, I think that's why I say it's a trade-off, right? You're trading off something, and I understand that by making the code, you restrict the number of users. Unless somebody is so clever that takes a picture and puts a friend somewhere.
I think a kind of big concern that's like kind of goes the unaddressed is like QR code is what if this Zoom is like online? So let's say Giovanni is presenting from Italy, then it's like on the web. I don't know how that would integrate with.
That would work, right? People would just.
Yeah, someone gets like let's say a QR code is like on a Zoom, and anybody on the Zoom.
Yeah, that can be.
So one thing that I would look at is maybe some light way of authenticating, like without interfering or having to. I think to be done seamlessly. Perhaps there's a key that gets exchanged at the beginning of the semester.
Yeah.
And therefore, right, scan the only one can scan and activate that. An implicit authentication.
Okay. Francisca, if you want to ask anything, you are free to ask.
It's maybe more a question maybe for you, I don't know, because that's back in the start. I was just curious how you involve the users. It is clear that the users are students, so probably WashU students during coming up with I was just very curious how that handles the processes. It allows to other fellow students that ask and stories that you came up with? What are they based on?
They are based on interview with contextual interview made with a professor here, and then each group have the charge to interview 1 or 2 persons. Someone interview people from the office, someone from the school, and that was not really extensive. We had just 1 session of that, but we had, I think, at the end there were 12 interviews in total, not many, but you know, the aim was not really to answer the brief, but to have a practice on this. But I think that for me, notwithstanding all the limitation in the path, in the involvement of the student, I think that notwithstanding all of these, at the end, there's been some proposal that I think will be interesting, because they will be submitted to Attila, which is the CEO of Airtame. And so we will see even there how good they are, you know, in a sense. So to me, the important thing is to show that even if with not a really smooth process, not a really expert people, it may be with people that don't believe too much in this because they are coming from engineering, some results can be get, you know, some things can come out. So maybe they will trust more this interdisciplinary approach, and they will pay more attention maybe in the future where they will join some design team in the university or in a company, because more and more, you know better than me, the interdisciplinarity now is the master. And so I think they will be more ready to face this opportunity to collaborate. And we did this without any discussion, because we used all deep cooperative process. No discussion at all the ideas were elaborated in, let's say, working together. Yeah, sure.
Probably the actual going out and learning how to interview and empathizing with potential clients was probably the most interesting part of the class, because it's something that is, you know, like when are you studying engineering as well?
Yep.
No? Well, okay, well, all of us, we study engineering, and then, like, you know, dealing with computers is like natural to us. So when you talk with other people, you realize that it's really not that simple, and it becomes our job to make it simple for everybody. And you also learn a bunch of things that you had like no idea of how different. We interviewed a couple of professors on campus and how they teach, and how did that end up like. We learned a lot about like pedagogy, essentially. Like one of the things that we didn't make it to the final slides, but one of our professors, or in a different class, he teaches essentially on PowerPoint, right? And the reason why he uses PowerPoint, even though it's an accidental feature that they have, and it is that you know that when you're on the editor mode, you know that you can see like all the slides on the site. Well, if you make that like bigger, he like artificially zooms in on that, then he has the slide that he's like teaching, and then he has the previous slide. And then the students, when they're lost, like and he switches slides, then they can still see the previous slide. So whoever's like falling behind can like catch up. Like I don't know, in a lot of math classes that I did, if like let's say you didn't understand one thing and the professor erases the board, you're screwed for the rest of the hour. Like there's no coming back unless you like stop it. So I thought that was really good. And like, you know, those are the kinds of things that us as engineers or people who are not teachers would never, like I would have never thought of that. And it's something so easy to implement. And it would make it like a really big difference. If the teachers who are deciding if they want to buy everything or something else, they'll see that and be like, oh, this is a great idea. So I think that was the biggest takeaway from the semester.
And that's very important skill to know who your users are and try to understand them, what they need, because very often users don't know what they really want. So listening to them, trying to translate how you can solve their problems without really doing what they want from you. That's, I think it's a big challenge that's very difficult for engineers sometimes. that's the takeaway, then it's a good skill to learn before.
Okay.
So for the second thing, I had a question that for not much for sentiment, but for guys that you raise hand, the potential to solve.
So I guess like maybe like so our initial purpose was to like kind of the structure when someone wants to raise their hand, but maybe the structure has their own case and like it won't make the class process as smooth as introduction. So that's one thing.
I wish that would happen. I don't know if interaction students are not. As much as actually recognizing when somebody is actually raising their hand. I would think that somebody has raised their hand. I think it's fine if there's 5 or 10 of them, but that's a clear message to the person. Right? Whatever he or she is trying to communicate, you know, kind of as a teacher. What I would not be okay with, and it has nothing to do with editing or I think etc. Maybe with the recognition software. But whenever you're recognizing something that will count for false negatives, right? You're raising your hand, but you're not being detected. Which I think is okay because you're still doing better than without that. But what is really annoying is false positives. Right? It happens often to me to recognizing somebody who's just stretching as a raised hand, so you can measure an algorithm. Right? So whenever you develop such algorithms, you always have to worry about the presence. Because they disrupt the flow for no reason. Disrupt the flow for a reason.
Yeah, I guess like I think that we work really what I put from parameters yeah, I think that recognizing it.
Yeah, it was more of a general comment on whenever you're relying on two tech things, you have always to worry about. Yeah. And I think there's I really like the mood detection scheme. And I think it's a good instantiation of a number of things you can do. So I expect this mood detection to be one small camera in a large class. It's a pretty challenging problem. Yeah, I mean, the division is the side. You could get even more, still anonymous, but more granular information. Facial distribution, to move them. There's a darker place of the room that you fall asleep more easily. Or the far we can already follow there. And privacy concerns, right? What would you have to do? Whenever you record here on Zoom, for instance, like let everybody know the functionality. Good, and a question for the group that was with the online or any.
Yeah, I support.
Technology from group 1 to the
Absolutely. I think we kind of alluded to. I think that like I think yeah, you just like you have to figure out some things, but maybe you're having a Wi-Fi issue, and like streaming video doesn't really make sense over data. So I think you need to make it very clear in the user interface on what can be done. Some problems are hard to solve there.
Is there any technology you can use for remote looking at how would that be?
So one of the framework already existing on it's Java based. So basically anything that any device that runs Java, this thing can work, and it's able to monitor any type of you have to set up the software or the firmware to interact with it, but it fully sets up an infrastructure for any type. Have your software on the device communicate with this infrastructure on the firmware that then can send signals to, and it gets dashboard like we were talking about. There's already a system in place for this, so that edge devices can be monitored, and I think this company just sells that platform that you can integrate. So in terms of like getting a prototype up, it should be really, really quick because there's more than one of those options out.
Two, you think about a seamless interaction between devices. There you're using a camera, for instance. Right? How would that interaction be set up? Right? Or
well, I'm just gonna do it on here, like on site. But yeah, that's definitely something. One of the challenges. Like numbers that's hard for that device like even though there's big thing hard. Honestly, it would just be better to kind of plan it ahead of time. You're going to integrate this thing and it would probably get more better. Yeah, maybe I think since we have access to
more generally, right? If you have things that you want to connect on the fly. Right? Like, is there like something that that allows?
No, not yet.
Let's go there.
Yeah, that will be.
Just give that grant to us.
No, I have to say that one thing that we missed, we didn't have the chance to have at all, was the mindset to iterate, because when you iterate in every phases, you have the opportunity to refine and address the issue more properly, especially in prototyping. And prototyping usually require you to iterate more and more. And prototyping is not just mapping the requirement in design parameters, but it's really exploring again and again, is just to put question to your idea in a material way. So all these questions that has been raised now are questions that in the prototyping phase, when you start to iterate, pop up. you have to address it because you have to produce something, let's say, interactive prototype. It doesn't mean that you use the final technology that you will adopt for implementing it, but you have to produce something that allow you to prove the concept in a real scenario. And that give you the real benchmark for assessing your idea. So, but that require more time, a bit more focused on one specific issue. Francisca.
Data privacy, have you checked or brainstormed on possible applications that can come up specifically on the new tracking the incidental, your students yourself, would you feel comfortable that the professor knows how many times you've been falling asleep or how many minutes during all your sessions at the end of the semester trying to make a grade on that?
Yeah. Well, that's definitely something we thought about a lot. Something I that was one of the possibility of having the ability to opt out. But like that was but we also talked about how the software itself wouldn't necessarily be like this person is doing this thing. It would just kind of like take that in and just kind of automatically, not automatically, but like it would just kind of throw all that data into the kind of like app. Like the professional won't necessarily see self-generate, feel tired itself. It would just be more like I don't feel like word.
And make sure that it's deleted after the session. Or other data sets.
I think that it already that ethical problem we're already dealing with it, because if you notice, like this, the class is being recorded right now. So if you want to look at us sleeping, you can go through those history on campus and you'll find.
Yeah. No,
Indeed. The professor trying to assess our
yeah, we discussed this also in the class, because they say at the end of the day we'll have the professor will just have an average mood of the class with some spot, but not the specific mood of a single person. Also because for the professor it will be important to have more the general mood of the class than not the specific mood of a single person.
And I guess it's more to
Louis. Yeah.
And if this is done on an edge device, instead of through, the feed is into Zoom, then there really should be much less of a data privacy issue, because then you can view it as a physical black box. If there's something in the front of the room that has one of the devices that we've learned about, the input is the camera and the output is just the average mood. Not only is data not recorded without physically messing with the device, there's no way to even see what's going on. It's just one input, one output. And so that can take away a lot of issues as well, because that means that since it's on the edge, it's also not in the cloud, that only the result.
Yes, I think it would be possible develop algorithm where they're saying bias. Say I like right on the board. Things get then projected or recorded. And so that's one case, or maybe you're just you're writing a tablet. It would be possible to say with one that recognizes the writing, and then so you can ask the monitor to do the computation for you. Examples of that side can be self-calculation, either checking or doing it, either doing steps. I think that would be a super cool. I check the user or How does it fit within your vision?
I mean, I know there's a lot of software out there that does do, like definitely text recognition in general, but I also think there is, I think I've used these before where you basically take a picture of your calculations. It says it, I think maybe Symbol Lab does this, and it basically can do the calculations right there for you. I guess I don't know exactly how that would fit in. That's a, like how they fit in with the Alexa idea or sort of connecting with Airtame, but
I think
certainly
that-
technology that exists.
Right, and I think the nice idea is that we sort of want to allow integration with Symbol Lab and with these other platforms. And so as Symbol Lab continues to develop and these other platforms continue to develop, which they will, it is that even if we're not necessarily the ones who are creating that, we're simply finding ways to merge those two platforms together. And so I think we hope that as they would continue to work and refine that process, we would be able to still seamlessly integrate that.
Okay, just last two remarks. In this effort, we have been constantly working with Giovanni from Italy. He took charge of the Thursday lab, exploring the technology, the enabling technology for rapid prototyping IoT solution based on microcontroller, voice recognition, and machine learning. So I would like to give the voice to Giovanni for his closing remarks.
Hello, can you hear me?
Yeah, can I?
Okay.
No, it's not concluding remarks from Giovanni. Not the concluding remarks there.
Ubi Maior. No, really, first of all, I would like to thank you everyone for the great job you did. And yeah, it's funny because right now it would be great if we were in a kind of time loop. And we already had just many of the idea that you design at the beginning of this class, because this was the perfect situation on how at least 50% of the thing you designed would be really helpful during this class in this partially remote and on-site course, because yeah, just exploring the real life, we was able to identify some possible ideas. Just also, I think, from this experience we had. I mean, I remember how many times I never heard what your question or your comments, or how many times I had no idea about your faces during the lessons. If how many of you were falling asleep, or how many of you think that some part of the lessons would be interesting, or maybe too easy or something understandable. And that was great. And it was really interesting how the real experience, it's really the basis for first empathize understanding the design challenges. And it was also nice, I think one comment of one of you that mentioned how, I mean, for many of you being engineer or computer scientist, it could be kind of a new experience to have these kind of discussions and how to get to an idea or to get to an aim we had at the beginning. And I had the same experience during my career. I started as a programmer. And then after many fights with designers or being involved in this design thinking experience, I totally changed my point of view. And I would like also to remark how in real life it could work about prototyping and design thinking. I have no idea how many prototypes or trashed idea I had in my garage, because maybe at the beginning I just started building something really easy, but at the end I realized that it wasn't useful for me, or I was trying, my idea was totally out of reality, so I doesn't really need it. Or I remember how many fights it avoid with my brother, because when he is a mechanical designer and maybe he wants to do something, he wants instructions. Okay, if you want, we have to do that. Give me exactly the quotes. Give me exactly what we should make. I said, I had no idea. I mean, we had an idea. We have to try if it makes sense, or there's no need to go over with that, or we will get just stuck at a certain point. So, I mean, let's start with prototyping and emphasizing on what you want to realize. I mean, it will avoid you a lot of fights if you start from the beginning trying to prototype and touch with your hands what is your final project, especially if there are many interactions involved with it. It's impossible to predict everything and pretend that someone can just draw the specifications or the blueprint of something in just maybe a conversation or a discussion, just two people around the table, just talking about. It's just not working. I mean, because it could be influenced by the personality of the people. It's much harder to get to a final point, especially when you want to tinker with no idea which is not perfectly shaped, and it involves the human being flexibility and also unconsciousness. So I hope that you really you enjoyed this new approach, and you will be able to reuse and exploit some of the tips that you learned during these 4 months. Congratulations to everyone. Thank you.
Thank you, John. Okay, I leave the room to Bruno, also because if this class has been possible, it is the fault of Bruno.
I think that the goal of the class is accomplished, right? This class was supposed to process. And as Antonio remarked several times, the end result doesn't really matter. With that said, right, I think if, for instance, FA was interested in continuing with the subset of you, right? Maybe there could be some other guidance or research project. I don't know how it's going to proceed, but if it does, then we'll take the liberty.
Yeah. The idea, the agreement is that we will define a day in January where the presentation will be done to the airtime staff. So they can. So let's say you have time to refine, of course, the idea as you want, because it doesn't matter what you presented today. You can exploit the remarks that have been made, also to prevent possible objection in that direction. And so to be ready for the possible presentation, I will write to Attila, the CTO of airtime, saying that the course was over and we have 4 proposals.